Good morning. Today we are going to start Unit 2, Solutions. What do you mean by a solution? A solution is a homogeneous mixture of two or more than two components. Homogeneous mixture means a mixture whose composition and properties are same throughout. Now, there are two components present in a solution. They are solute and solvent. Solute is the component present in smaller amount and solvent is the component present in larger amount. And it is the solvent that determine the physical property or physical state of a solution. That is, whether the solution is a solid, liquid or gas. Now in this unit, we will discuss binary solutions. Binary solution means a solution with two components. So one component will be a solute and the other will be a solvent. Now the solutions are of great importance in our daily life. And the importance of solutions depends upon the composition of the solution. For example, 1 ppm, ppm means parts per million, 1 ppm of fluoride ion in water will help to prevent tooth decay, whereas 1.5 ppm of fluoride ions will cause tooth decay. And also, high concentration of fluoride ions is poisonous. For example, sodium fluoride is used in rat poison. Also, we have alloys like brass, bronze and German silver. We know that brass is an alloy of copper and zinc. Then German silver is an alloy of copper, zinc and nickel. And bronze is an alloy of copper and tin. Now you know that they have different properties. So the properties of solutions depends upon its composition present. So solutions are of great importance in our day-to-day life. And in this unit, we will be discussing some important properties of solutions like vapor pressure and colligative properties. Now let's see the types of solutions. There are mainly three types of solutions. First one is solid solution. The second type is liquid solutions. And the third type is gaseous solution. And I told you it is the solvent that decides the physical property of the solution or the physical state of the solution. So in solid solution, the solvent will be a solid solvent. And the solute can be a solid, liquid or gas solute. Now in liquid solution, the solvent will be a liquid solvent and the solute can be a solid, liquid or gas solute. Whereas in gaseous solution, the solvent is a gas. So gas solvent and the solute can be solid, liquid or gas. So these are the three types of solutions depending upon the physical state. Solid solutions, liquid solution and gaseous solution. In solid solution, the solvent is a solid, liquid solution, solvent is a liquid, whereas in gaseous solution, the solvent is a gas. Next, we are going to discuss the different methods for expressing concentration of a solution. Concentration of a solution. Now, concentration of a solution means the maximum amount of solute that can be dissolved in a given amount of solvent. There are different ways of expressing the concentration of a solution. The first one is percentage. The percentage of a solution can be expressed in terms of mass percentage, volume percentage, and mass by volume percentage. So we are going to discuss each type of percentage in solution. The first one is mass percentage. Mass percentage means the mass of solute in grams dissolved in 100 gram of solution. So if we are to write an expression for mass percentage, we can write the expression as mass percentage is equal to mass of solute in grams divided by total mass of solution into 100. This is the expression to find mass percentage, that is mass of solute in grams dissolved in 100 gram of solution. Or the expression to find mass percentage is mass of solute in gram divided by total mass of solution into 100. For example, 10% glucose solution by mass. 10% glucose solution by mass means that 10 gram of glucose is dissolved in 90 gram of water, so that the total mass of the solution will be equal to 100 gram. So this is the meaning of 10% glucose solution by mass. 10 gram of glucose is dissolved in 90 gram of water, so the total mass of the solution is 100 gram. So this is mass percentage. Now the next type of percentage is volume percentage. Volume percentage. It is the volume of liquid solute dissolved in 100 ml of solution. Volume of liquid solute dissolved in 100 ml of solution. So when we write the expression for volume percentage is equal to volume of solute divided by total volume of solution into 100. For example, when you hear 10% ethanol, 10% ethanol solution by volume. (10% ethanol solution by volume means that 10 ml of ethanol is dissolved in 90 ml of water, so that total volume of the solution is equal to 100 ml. Now another example for this is 35% ethylene glycol. 35% ethylene glycol. 35% ethylene glycol means 35 ml of ethylene glycol in 100 minus 35 ml of water, so that the total volume of the solution is 100 ml. Okay, now this 35% ethylene glycol is used as an antifreeze. Antifreeze, that is used to cool the engines in cars. It's used as an antifreeze in cars, that is to cool the engines. That is 35% ethylene glycol will lower the freezing point of water to minus 17.5 degrees Celsius. So we know that the freezing point of water is 0 degrees Celsius. So in cold countries, to prevent that freezing of water at 0 degrees Celsius, we add 35% ethylene glycol to radiators in car engines, so that the freezing point of water will be lowered to minus 17.5 degrees Celsius. Now, the next percentage term is mass by volume percentage. Mass by volume percentage. Mass by volume percentage is the mass of solute dissolved in 100 ml of solution. Or we can write the expression as mass by volume percentage is equal to mass of solute in gram divided by volume of solution in milliliter into 100. This is mass by volume percentage. For example, 10% solution of sodium carbonate means 10 gram of sodium carbonate is dissolved in 100 ml of solution. 10 gram of sodium carbonate is dissolved in 100 ml of solution. So these are the three percentage terms used to express concentration of a solution. First one is mass by mass percentage, second is volume by volume percentage, and third is mass by volume percentage. Okay. Now the next term used to express concentration is molarity. So number 2 is molarity, denoted by capital M. Now the molarity is the number of moles of solute dissolved in 1 liter of solution. That is, the expression is molarity. M is equal to number of moles of solute is denoted by MB divided by volume in liters. And we know NB is equal to number of moles of solute. Now in the chapter solutions, we always denote solvent with capital A and solute with capital B. So NB means number of moles of solute. Number of moles of solute is equal to given mass, that is WB divided by molar mass of solute. Given mass of solute by molar mass of solute. Now substituting this expression in the molarity equation, we get M is equal to WB by MB into V in liter. Or M is equal to, suppose the volume is in milliliter, then WB by MB into V in milliliter means into 10 raised to 3 or into 1000. You get molarity. Now the unit of molarity is mole per liter. Mole per liter or molar or capital M. So if you see 0.25 molar sodium hydroxide solution. This means that 0.25 molar sodium hydroxide solution means that 0.25 moles of sodium hydroxide is dissolved in 1 liter solution. 0.25 moles of sodium hydroxide is in 1 liter solution. That is the meaning of 0.25 molar sodium hydroxide solution. Now the next term, third term used to express concentration of solution is molality, denoted by small m. Molality is the number of moles of solute dissolved in 1 kilogram of solvent. So when we write the expression for molality, small m is equal to number of moles of solute dissolved in 1 kilogram of solvent. Solvent is denoted by WA in kilogram. Again we know NB is equal to WB by MB, given mass by molar mass. So M is equal to WB by MB into WA in kilogram. Now suppose you have the expression that is the mass of solvent in gram, then molality M is equal to WB by MB into WA into 10 raised to 3. Here WA will be in gram. Now the unit of molality is mole per kilogram or molal or small m. This is the unit of molality. So for example, 1 molal solution of KCl. 1 molal solution of KCl means 1 mole of KCl is dissolved in 1 kilogram of solvent or 1000 gram of solvent. So this is molality. Now the next concentration term, that is number 4, is mole fraction. Denoted by X. Now mole fraction, the definition is mole fraction of a component is a fraction obtained by dividing the number of moles of that component to the total number of moles of all the components present in solution. If Na and Nb represents, Na represents number of moles of solvent and Nb represents number of moles of solute, then mole fraction of solvent Xa is equal to Na divided by Na plus Nb. That is number of moles of solvent divided by total number of moles of solute and solvent present in solution. Suppose we want to find the mole fraction of solute, then Xb is equal to Nb divided by Na plus Nb. That is number of moles of solute divided by number of moles of solvent plus number of moles of solute in solution. Now, there is no unit for mole fraction. It's a dimensionless quantity. Now, the sum of mole fraction of all the components present in a solution is unity. So, the maximum value for mole fraction is 1. Or we can write, if there are different components like A, B, C, D, etc. present in a solution, then the sum of their mole fractions, that is Xa plus Xb plus Xc plus Xc plus etc. will be equal to 1. And it's a dimensionless quantity. Now, the next concentration term used is, parts per million. Parts per million, or the short form is ppm. Now this concentration term ppm or parts per million is used to express concentration of substances when they are present in very minute quantities, especially for the pollutants, the concentration of pollutants in the atmosphere, we use ppm. Now ppm definition is, ppm is the mass of solute dissolved in 1 million parts by mass of solution. Parts per million is the mass of solute dissolved in 1 million, that is 10 raised to 6 parts by mass of solution. And the expression for ppm is, ppm is equal to, parts per million is equal to mass of solute divided by mass of solution into 10 raised to 6. So this is the expression to find ppm. Okay, so these are the different concentration terms used to express